Mars beckons. The red planet, a tantalizing beacon in our night sky, has long captured the imagination of dreamers and scientists alike. Its reddish hue, visible even to the naked eye, hints at mysteries and adventures waiting to be uncovered. A red jewel in the night sky, promising adventure and a new home for humanity. The allure of Mars is undeniable. It represents the next frontier, a place where we might one day build new societies, explore uncharted territories, and perhaps even find signs of ancient life. But Mars is a harsh mistress. Thin atmosphere, freezing temperatures, and a lack of breathable air are just the beginning of the challenges. The surface is a barren, rocky expanse with temperatures that can plummet to -80 degrees Fahrenheit at night. Water, a crucial element for life, exists mostly as ice, locked away in the polar caps or hidden beneath the surface. One danger lurks unseen, silent but deadly. Radiation. Unlike Earth, Mars lacks a protective magnetic field, leaving its surface exposed to the relentless bombardment of cosmic rays and solar radiation. This invisible threat can damage cells, increase cancer risks, and pose serious health hazards to any would-be explorers. It's a constant threat to any brave soul venturing beyond Earth's protective atmosphere. Astronauts on Mars will need to take extraordinary measures to shield themselves from this radiation, whether through specially designed habitats, protective suits, or even underground living quarters. On Earth, we're shielded by a magnetic field and a thick atmosphere. These natural defenses deflect and absorb much of the harmful radiation from space, creating a relatively safe environment for life to thrive. This protects us from the constant bombardment of cosmic rays and solar flares. Without these shields, life on Earth would be much more precarious, and our planet would be a far less hospitable place. Mars unfortunately lost its global magnetic field long ago. This loss has left it vulnerable to the harsh conditions of space, stripping away much of its atmosphere and leaving it exposed to the full brunt of cosmic and solar radiation. Its atmosphere is a mere wisp compared to Earth's. This thin veil offers little protection from the dangers of space, making the surface of Mars a challenging environment for human habitation. This means radiation is a much bigger problem for anyone trying to live on the red planet. Future Mars colonists will need to innovate and adapt, developing new technologies and strategies to survive and thrive in this unforgiving environment. The dream of making Mars our second home is fraught with challenges, but with determination and ingenuity, it remains within our reach. Radiation is essentially energy traveling through space. It comes in many forms, some of which are visible to the human eye, while others are completely invisible. This energy can travel vast distances, crossing the void of space and interacting with anything it encounters. Some of it is harmless, like the light and heat we get from the sun. These forms of radiation are essential for life on Earth, providing the energy needed for plants to grow and for our planet to maintain a habitable temperature. Without this radiation, life as we know it wouldn't exist. Other types, however, are ionizing. This means they can strip electrons from atoms, damaging DNA, and increasing the risk of cancer and other health problems. Ionizing radiation is much more dangerous because it has enough energy to alter the very building blocks of matter, leading to potentially severe biological effects. There are two main types of radiation we worry about on Mars: galactic cosmic rays and solar energetic particles. These forms of radiation are particularly concerning because Mars lacks a strong magnetic field and thick atmosphere, which on Earth help to shield us from these harmful particles. Galactic cosmic rays are high-energy particles from outside our solar system. They constantly bombard Mars like a drizzle of tiny bullets. These particles are remnants of supernova explosions and other high-energy events in the galaxy, traveling at nearly the speed of light. Solar energetic particles, on the other hand, come from the sun, blasted out during solar flares and coronal mass ejections. These events release massive amounts of energy, sending particles hurtling through space at incredible speeds. These are less frequent but more intense bursts of radiation, like a sudden hailstorm. When a solar storm occurs, the intensity of radiation can spike dramatically, posing immediate and severe risks to any unprotected life or equipment in space. Both galactic cosmic rays and solar energetic particles pose a significant hazard to astronauts and any future Martian colonists. Without adequate protection, prolonged exposure to these types of radiation could lead to serious health issues, including increased cancer risk, damage to the nervous system, and other potentially life-threatening conditions. As we plan for human missions to Mars, understanding and mitigating these radiation risks is crucial for the safety and success of our endeavors. So how do we protect ourselves from this invisible enemy? One way is to use traditional radiation shielding materials. Think of them like really thick, dense walls. Lead is a great radiation shield, but it's heavy and expensive to transport to Mars. Other options include concrete, water, and even Martian soil itself. The idea is to put as much mass as possible between the astronauts and the radiation. The thicker and denser the material, the more it slows down and absorbs the harmful particles. Water is surprisingly effective at absorbing radiation, and it has the added benefit of being useful for other things on Mars, like drinking, growing crops, and even producing rocket fuel. One concept involves building habitats with thick layers of water incorporated into the walls or surrounding the habitat. This could provide effective shielding while also serving multiple purposes. Section 5. Going underground, safety and depth. Another option is to simply go underground. Martian soil, particularly if it's compacted or located deep enough, can provide significant protection from radiation. Habitats could be built in existing lava tubes, caves formed by ancient volcanic activity, or buried beneath several meters of Martian regolith. This would offer natural shielding from both galactic cosmic rays and solar energetic particles. Section 6. Magnetic fields, a force field for Mars? Perhaps the most ambitious solution is to create an artificial magnetic field around Mars or individual habitats. Remember Earth's magnetic field? It acts like a giant shield, deflecting most of the harmful radiation from the sun and beyond. Generating a planet-scale magnetic field would be a monumental engineering challenge. It's not impossible, but it would require technology that's currently beyond our reach. However, creating smaller, localized magnetic fields around habitats or spacecraft might be more feasible. These magnetic bubbles could deflect radiation, creating safe zones for humans and equipment. Section 7. Hybrid solutions. Combining the best of both worlds. It's likely that the most effective radiation protection for Mars will involve a combination of different methods. A multi-layered approach could include traditional shielding materials, water walls, underground habitats, and even localized magnetic fields. For example, a habitat could be built underground or within a lava tube, with a layer of Martian regolith piled on top for additional shielding. The habitat itself could have water-filled walls, and a compact magnetic field generator could provide an extra layer of protection during solar storms. Section 8. The future of shielding innovation for survival. Research into radiation shielding is ongoing. Scientists are exploring new materials like lightweight composites and even self-healing materials that could offer better protection with less weight and cost. Nanotechnology and biotechnology could also play a role in developing advanced shielding solutions. Imagine tiny robots that repair radiation damage in real time or genetically engineered organisms that can absorb and neutralize harmful particles. Section 9. Shielding, a necessity for Martian dreams. Radiation is a formidable challenge to our dreams of colonizing Mars. The red planet, with its thin atmosphere and lack of a magnetic field, exposes its surface to high levels of cosmic and solar radiation. This radiation poses significant risks to human health, including increased chances of cancer, damage to the central nervous system, and acute radiation sickness. But it's a challenge we can overcome. Through rigorous research and innovative engineering, we are developing advanced materials and technologies to shield future Martian settlers from these harmful rays. By combining our ingenuity and technological prowess, we can create habitats that not only protect but also sustain human life. These habitats will be equipped with multi-layered shielding, utilizing materials like polyethylene and regolith, the Martian soil, to block and absorb radiation. We can develop effective radiation shielding solutions that will allow humans to live and thrive on the red planet. These solutions are not just theoretical, they are being tested and refined in labs and simulations on Earth, preparing us for real-world application on Mars. Shielding is not just about protecting astronauts on short missions, it's about ensuring the long-term health and survival of a future Martian civilization. This means creating environments where families can live, children can grow, and communities can flourish. It's about building a new world where humans can thrive, with greenhouses to grow food, medical facilities to care for the sick, and schools to educate the next generation of Martian pioneers. As we venture further into the cosmos, the lessons we learn about radiation protection on Mars will be invaluable for exploring and settling other worlds. Each step we take on Mars brings us closer to understanding how to live sustainably beyond Earth. The knowledge gained from these efforts will not only benefit Mars missions, but will also enhance our capabilities for deep space exploration. The innovations in radiation shielding will be crucial for missions to the Moon, asteroids, and beyond. Our journey to Mars is a journey of innovation and resilience. It is a testament to human determination and our unyielding spirit to explore the unknown. With each hurdle we overcome, we gain valuable experience and knowledge. These challenges push us to innovate, to think creatively, and to work collaboratively. We inch closer to making humanity a multi-planetary species. The dream of living on Mars is not just a distant possibility, it is becoming a reality, one breakthrough at a time.